In this video, I will be describing our system wiring method, but first I need to show you a recent change that affects your choices in module selection. Prior to 2024, the base of our system was composed of a combination of two modules. The first being the LSS2381 Room Interlock Control Module, and the second being our LSS2384 Local Interlock Module. Every system installed needed the Room Interlock Control Module to arm and disarm the room, and the Local Interlock Module to bring in system power and attach to your laser or shutter for its interlock connection. Since every module needed these, we called this the system base. Now in 2024, we have a new module called the LSS2382 Main Control Module that combines the functions of these two modules and adds a high security key control for arming, disarming, and lockout of the entire system. Rooms can still be designed using the 2381 and 2384 modules as the base, but from here forward, we will be recommending the new Main Control Module since it simplifies system wiring and adds high security key control. Now I'll describe the system wiring method that makes our product so unique and desirable. Let's expose the terminals and see how the modules wired up. We start with the connection of the system power, which is fed by a low voltage 24 volt DC power supply. Now let's place a start jumper and an end jumper. These two jumpers are needed at the start and end of every system to loop safety logic through the interlock chain. Finally, the main control module has two sets of dry contacts that can go to the client's laser or shutter controller. This module, as you see it wired right now, would be fully operational to arm and disarm the interlock. But of course, we're going to want to add other modules to the system. Let's remove the start jumper, and our client wants to add a few items at the front door of the lab. We're going to run our 8-conductor main interlock cable over to an emergency crash switch and continue the run to a non-defeatable door monitor module. From here, we run the cable out into the hallway and insert a laser warning module. Okay, looks good. So let's terminate it again with the start jumper on the open end. This system as shown now is fully operational. Power, system status, and control signals are carried through the 8-conductor interlock cable. Now let's imagine that a couple years later they find they need to leave the laser running unattended, which means they need to be able to enter and leave the laser area without tripping the laser. In this case, we would simply remove the non-defeatable door monitor and insert our defeatable access control kit, which gives authorized personnel the ability to enter and exit the laser-controlled area without tripping the laser. The system again is fully operational. Now let's imagine some additional remodeling has occurred and they added another laser table and a door at the back of the lab for emergency exit. This is no problem. As you can see, we would remove the end jumper and extend the 8-conductor interlock cable to the second laser table, where we would install a local laser relay, perhaps another emergency crash switch, and at the rear door, we add a non-defeatable door monitor. Finally, we place the end jumper on the last module in the chain, and the new system is fully operational. This concludes our demonstration of system wiring. When you work with us to design your room, you will be receiving a complete wiring and layout plan specific to your lab space. In addition to being used for installation, this plan is useful for your electronic documentation of the laser interlock in your Laser Safety Operational Procedures document. If you have any other questions, please contact us or review the system manual specific to the module connections.